So now, see, this is the experiment. These are the tourmaline crystal. It's one of the element. Okay, tourmaline crystal, A and B. A means it's nothing but tourmaline crystal which polarizes. Okay, polarizer. What about this one? This one is also a polarizer itself. But here it is used to check whether it is already polarized. That is why we say this is analyzer. That means analyzers. Okay, that's why. Analyzer. So hope this diagram is clear for you. Now, what is the coming light here? Light comes in this particular direction, correct? Like this. So whether it is polarized already? No. So from sun what we get? We get the unpolarized light. So that means there is actually some certain amount of polarized light is there, but that we'll see later. Because of scattering also polarization takes place. But let us take from one monochromatic source. Don't want sun actually, because some of the sun also, polarized light also will be incident on Earth's surface because of scattering. But let us take, what I am going to take right now is, let us take a monochromatic source from which unpolarized light is incident on the polarizer A, which is tourmaline crystal. So tourmaline crystal like this. Okay. So this is, you have to draw this, okay. Unpolarized light. Next, unpolarized light is over. But what happens here after it passes through the crystals which are polarizers? Of course, light has to be polarized, correct? So this is polarized light. Let us show that. So how to, okay, sorry, here space is less. Unpolarized. Done. How to show unpolarized light? Light has to be containing the vibration in all the direction. That means up and down, horizontal. That side, your side. Given by a dot. Correct? Yes. Next, up and down. And a dot. Dot means horizontal. Like Z direction is there, no? Like that. So light will, the unpolarized light which is received from a monochromatic source is actually incident on the polarizer, the crystal called tourmaline crystal. So what happens, this tourmaline crystal will restrict the horizontal vibration here. You can see the axis of polarization I have shown you, dot dot line, straight. That means only through this axis light passes. That means what happens, what about the Z direction vibration? They have to get cut, only the Y direction, correct? So here vibration will be like this. What about dot? No dot, because it is already cut. The vibration, that means intensity has reduced. Polarization has taken place. So the polarized light will look like this. Only vertical vibrations are present. Horizontal vibrations are gone because of the polarizer. Next, what else we have here is analyzer. This analyzer is there. No, this is also tourmaline crystal only. That is also tourmaline crystal, same as A. We have kept that B, that means the analyzer we usually say. No, why? Because we are analyzing using that tourmaline crystal. That is also polarizer only. But here vertical vibrations are coming, right? That vertical vibrations are passing through this. Now look at here. A and B are actually kept with the same parallel method, with the same axis of what? Polarization. So what happens? The vertical polarized light has to pass through this, correct? So here So light will emerge out. Light with we can take maximum intensity also we can write. Max intensity. We can ask. So that means the polarized light will be having more intensity than unpolarized light? Of course, no. For the polarized light, this is maximum because the axis of polarization of A and B, that means polarizer and analyzer, is one and the same. That is why whatever the polarized light is there after the crystal A passes, that passes easily through B also, because B is kept such a way that its axis of polarization of analyzer is one and the same. So it passes. So you will get intensity of light, bright spot you will get here. Hope you understood. Now what I do is, I will move forward. This diagram, I think it's very clear for you. Now next diagram is, I will continue in the other part of the board. So, this is the first case, correct? Now same diagram I will draw once again. Means, yes, of course, sorry. Okay. Now let us draw the polarizer analyzer here. A is kept as it is like previous one, but now what I do is, the axis of polarization was there, no, for the previous one. Here, I will change it. Okay, so now I am going to change this. Like how I slowly make a change of axis of this. That means like this. Okay, hope this is clearly visible for you. So light will enter this. Here also light will enter. So now there is some difficulties, right? Because like previous diagram, this diagram has got slight variation. What is that? The plane of the axis of polarization of the analyzer has changed. So this is analyzer, this is polarizer, this is A, this is B. So this is polarized light. What about this? Here it is polarized light. Here what happens? Light. Polarized light, okay. Polarized only with minimum intensity. With minimum intensity. Now let us show the vibrations, okay. Vibrations looks cool, right? Arrow marks. Fine. Hope this is clearly visible now. Yes. So this is unpolarized light. That means in all the direction light will be having vibration. Up and down, horizontal, z axis, correct? Dot. Here, up and down, dot, because this is unpolarized light. In all the direction light is actually having vibrations. Once it enters the polarizer, you can see the axis of polarization. It is vertical. That means it passes only vertical vibration and kills or restricts what? Restrict the horizontal vibrations. So, same as the previous diagram, you can see only vertical vibrations will be present here, like this. So after entering A, what happens? The unpolarized light will be polarized, horizontal vibrations are cut off, or horizontal vibrations are actually restricted, only vertical vibrations are seen. Am I right? So next, what happens here? Look at the B, analyzer. What happens here, analyzer B? Here, okay, I have to because I am not going to show any vibrations here, but problem is you have used light as a ray in ray optics, and I don't want you to consider this one as okay, light is going nicely. Don't want. I will use dotted line. That means reduced intensity of light is present. Okay. Yes. Now you see here. Look at the analyzer. Okay. Look at the analyzer. This analyzer is not having its axis of polarization or axis through which vibration will pass as same as that of the polarizer. This is vertically placed properly. That is not placed properly vertical in the sense. So what happens? The vertically polarized lights are there. No, they try to reach this B. When they reach B, they find what? Imagine. See how it is easily imaginable. Means imagine that your door at your home is placed inclined like this. Door. If the door is placed exactly in this, right now how it is placed in everyone's home, vertical, right? So we easily enter. If the door is placed inclined like this, do you feel that you can easily enter like how you are entering right now? Not possible, right? Yes, same thing happens here. So what happens to the vertical vibrations of light? They find obstacles. They are not able to pass through the crystal because crystal axis of polarization of the analyzer is tilted, not same as that of A. So light doesn't have any intensity here, it becomes dark. That means we cannot say that zero, slight intensity will be there, but very, very minimum intensity. Okay? Because it is slightly tilted. If it is exactly kept horizontal means, of course, we can say that it is zero, but it is not tilted 100%, right? Like for horizontally, slightly it is tilted, so intensity is less. So polarized light with minimum intensity, that is a final observation we can do. Okay. So students, I repeat once again. Okay. Yes. So we have discussed about what is that? Polarization topic. So in polarization, what is a polarization definition? So polarization means light in which is a statement or is a phenomenon in which vibrations of light is confined or restricted to single plane. So vibrations, I have shown you people how vibrations are actually can imagine. Okay, transverse wave vibration will be in all the directions like this. If you reduce to one single plane means vertically it will come. So that's how. So how they perform the experiment, you can see here the experiment involves two tourmaline crystals, unpolarized, a monochromatic source of unpolarized light. And tourmaline crystals initially they kept at the same axis of polarization. Look at here, vertical, exactly like this it is kept. So easily we can say that the polarized light, what is there which comes after the polarizer, will enter the analyzer easily and comes out. And again what you get, light with a polarized light with maximum intensity. Okay, like that you can write. Already polarized, right? Polarized light with maximum intensity or more intensity. Correct? Diagram. Next, what happens? Next is, if the analyzer B is slightly tilted from the initial position, if the analyzer is slightly tilted from the initial position, what happens? Of course, we know that whatever the unpolarized light comes, of course, it gets polarized. Once it polarizes, a polarized light will travel, and when it tries to enter the analyzer, that means one more tourmaline crystal which has got the axis of polarization vertically, right now it is tilted. So what happens? This light wants vertical, for example, I told you, like door. If the door is kept slightly tilted, means it's very difficult for us to enter easily, like how we enter right now. Same thing happens for the vertical vibration of light. So what happens at the end? The intensity of light will be minimum. Okay, fine. So draw the diagram neatly, both diagrams, and like how I explained, that is the way of explaining. So you better explain, okay? Write down in notes, like how you understood technical terms, what I have shown or written, use those. Okay, fine. Next, so polarization in this one of the very important experiment we have discussed right now. That is actually for what? For understanding how light behaves once it is polarized, means what are the constraints, what are the problem in which light will face when it enters some crystals, tourmaline crystal for example. Okay. Yes. So now what we do, definition of polarization is over. And I told you people, the phenomenon which proves that light is transfer in nature is also polarization. Take down. Okay. So next, let us go for next one. What is that? Same, almost like a diagram concept, where we come across plane of vibration and plane of polarization. Plane of vibration and plane of polarization. These are two technical terms we require. I will explain this by using or by drawing the diagram, okay, so that it will be easy for you to understand. So let us take same way diagram. Okay. So light, just so ray of light, crystal, I'll draw, okay, here. Okay. Once light passes through the crystal, what happens? Gets polarized. Am I right? So now, using different, okay, first I will show the polarization. So what is that? Light enters this. So vertically, that means it is unpolarized, correct? Before falling on the tourmaline crystal, it is unpolarized. That means vertical as well as horizontal dot vibrations will be present. Now we know that what the crystal or the tourmaline crystal, which is kept such a way that its axis of polarization is vertical. So only vertical lights will come out, vibration light will come out. Horizontal is cut off or restricted or confined. Yes, see, only vertical will come out. Okay, so now what is plane of vibration is the question. Plane of vibration means it is a plane in which vibrations of light is present after polarization. Okay, so what is that? Look at here, this vertical plane is itself what? Vertical plane itself is the plane of vibration. That I will show like this, okay, using colored chalk. See, this is vertical vibration. That means these vibrations after polarizations are vertical. That means like this, correct? That means in y direction it is minus y to plus y, right? That's what I am explaining here, okay? Hope you can make out. Yes, hope you can see the vertical plane. Yes, the plane which consists of vibration of polarized light is called plane of vibration. Here the plane which consists vibrations are vertical. So this pink colored dotted line is vertical plane. Okay. Now what is plane of polarization means? Plane of polarization means the plane where vibrations are cut off or restricted. Where it is restricted? Whether vertical vibrations of light is restricted? No, it is allowed. That means what is that? Vibrations which are polarized. That means which are restricted, which are cut off. What is that? Horizontal, correct? So the plane which contains polarized vibration is nothing but what? Plane of polarization. That means there is no intensity itself. There won't be any vibrations. That means horizontal. That means z direction, like this, towards you. But how to show here? 3D diagram. Okay. How to draw 3D diagram? Very simple. I'll just try. Okay. So the blue dotted plane, that means z direction horizontal plane is there, no? That is nothing but plane of polarization. Okay, yes, this is visible very clearly for you. I can zoom. So the plane, we have to write down, okay? Plane of vibration means what? plane of vibration means, so when unpolarized light is passed through the tourmaline crystal here, the vibrations which are here, which one? Vertical one, correct? So vibrations here are vertical one. So the plane which contains vibration of light, okay, that means when unpolarized light pass through tourmaline crystal, okay, when unpolarized light is passed through tourmaline crystal, the emergent light is plane polarized. In which direction? Vertical direction it is coming out. Polarized in which direction? Horizontally it is cut off. Horizontal vibrations are cut off. That means polarized along horizontal. Allowed in which direction? Only vertical vibrations are allowed. So the plane containing the vibrations of light is called plane containing the vibrations. The pink dotted line is nothing but, because only vertical vibrations are there. No, so vertical plane which is there, which containing the vibration is called plane of vibration. Next, what is that? The plane of polarization is the plane which no vibration occur. That means here, look at here. Here, horizontal dots, horizontal vibrations, that direction vibration coming towards you, no, and entering the board, that is cut off. So that is nothing but polarized plane. That means you can see the plane which doesn't contain any vibration is called plane of polarization. That means it is cut off. So this is plane of polarization, and this is plane of vibration. Plane of polarization, plane of vibration. Okay, take down neatly. Hope you understood now. Okay, so plane of vibration, plane of polarization, everything is mentioned here. So take down neatly. So today in this class, we have discussed about the phenomenon of light, and that phenomenon was polarization. Already, like reflection, refraction, diffraction we have learned. Today we have learned a new what is that? Phenomenon of light. The phenomenon which proves that light is transverse wave is nothing but polarization. What is polarization? The phenomenon in which light vibrations are restricted to single plane. How it is possible? It can be done by using some crystals, for example tourmaline crystal, and we have to do some experiment. Already I have explained you that experiment here, and something called plane of vibration, plane of polarization I have shown you here. Hope I have convinced you. Okay, that means you understood. Any doubt means once again you repeat it. Okay, that means video. It's not that rocket science, something like that. Easy it is. Okay, so hope you understood about the vibrations of light and some explanation what I have given to you people. Okay, so polarization concept, plane of vibration, plane of polarization is explained here. Diagram, I hope you are going to take it very neatly. I want everyone to send the answers, in the sense the notes, points, diagram what you have taken from each videos, what you do. Okay, you have to send as soon as possible. Okay, those who are showing less interest, those who are having laziness in order to send the homework, all those things, they will be punished, because second year is your life turning point. Am I right? You are going to decide your future here. Right now you have to wake up. Now if you don't try, now still you are just having you are in a easy mode, means definitely you are going to repent. That's why do hard work, show interest in your studies. Okay, so when you are focused, you will get interest.